Hello everyone, this is Fahad Mirza and I welcome you to my channel. In the past, I have covered various grammar correction models and I just stumbled upon this bit of an older model which is T5 based grammar correction model. Seems like a good model, does only one thing and does it nicely. So in this video, we are going to install this T5 based grammar correction model locally and we will see on few of the prompts as how exactly it corrects and how accurate the correction is with the help of this model. So let's get started. Let me also give a huge thanks to Massed Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. So this is my Ubuntu system and this is my GPU card NVIDIA RTX 6000 with 48 GB of VRAM. Let's quickly create a virtual environment. And now let's install some of the prerequisites which include torch, transformers and happy transformer. So this is a bit of a different thing about this model that it uses happy transformer in order to do the inference with the model. Let me give you a very quick overview of what exactly this happy transformer is, because this is one of the reasons I wanted to cover this model. Seems quite interesting. So transformers library, we already know, was developed by Hugging Face that provides a wide range of models for various NLP tasks like classification, language translation, question answering and text generation. Whereas Happy Transformer is a Python library that has been built on top of Transformers library. It provides a simpler, more user-friendly interface for using transformer-based model for text classification and a lot of other NLP tasks. So major difference between transformer and happy transformer is that it is happy transformer is built on top of transformers and make it easier. Also does a lot of things similar to what transformer does. It also has support for deep speed, Apple MPS, WAN-DB. You can push models to direct to Hugging Face Hub directly. Plus, the data supplied for training is automatically split into portion for training and evaluating with the help of this happy transformer. So all in all, makes it a bit easier to deal with transformers library. If you ask my personal opinion, I think that the existing transformers library is easy enough to work with, and Hugging Face has already made it a lot easier, but we have yet an alternate tool to, so why not? And it is Apache 2 license. Anyway, let's go back, and it is still installing the stuff because I was building this transformers from the source. That is why it is taking a bit of a time. And now let me launch my Jupyter notebook, and we will download and play with this model with happy transformer in that notebook. Okay, now let me show you that how easy it becomes from happy transformer to download the model. So all we need to do is to run this single line. It is going to download the model, tokenizer, whatever is needed, and we are importing these settings from happy transformers. But as I said earlier, now we have that pipeline concept and object from Hugging Face transformers library, which is, I believe, as simple as it could get. Anyway, so let me run this. And you can see that it is downloading the model, which is very small, just close to 900 meg. And it has downloaded the model, downloaded the tokenizer, and not only it has downloaded it in PyTorch format, but also in the safe tensor, which is a better option. And that is all done, and it has put it on to our CUDA device, so it has automatically detected our GPU, which is good. But yes, of course, given the size of this model, you can simply run it on CPU too. And let me now show you how you can simply do the inference with this happy transformer and this model. So we are just giving it number of beams, and both of these num underscore beams and min length, they are hyperparameters, and they primarily control the generation process or our output. Num underscore beam is an integer that specifies the number of beams to use during text generation. Beam search is a very well-known heuristic search algorithm used to generate text by exploring multiple possible sequences of tokens, for example, words or characters at the same time. Num underscore beams controls the number of parallel sequences to generate and evaluate at each step. A higher value for num underscore beams allows the model to explore more possibilities, which can lead to better quality text but also increase the computational cost. And 5 is, I think, it's okay in between. Whereas min underscore length is an integer that specifies the minimum length of the generated text. This hyperparameter ensures that the generated text meets a certain minimum length requirement, which can be useful in application where a minimum amount of text is required. For example, here we have set that beam search 5, which means that it is going to use beam search algorithm with 5 parallel sequences to generate text, and the generated text must have a minimum length of 1 token, and that token could be character or a word. Okay, so let me now run this where we have given it a bad grammar sentence, and it should be prefixed with grammar colon, and we are saying that this sentence has bad grammar. So, and we have passed these arguments. Let's run it to see what it produces. There you go. It's very quick. It says moving the model to CUDA, initializing a pipeline, and then it says this sentence has bad grammar. Let me try to give it a bit more complex. So I have just changed the code and I have just given it a bit more complex sort of grammatically incorrect sentence. In this one, what I'm testing is that incorrect subject verb agreement, missing articles, inconsistent verbs and tenses, lack of punctuation, spelling mistakes. Let me run it and let me also show you the VRAM consumption. It is already loaded onto the GPU. So it is consuming around, I would say 1357 meg, which is quite low. You can easily run it on CPU too. Okay, so let's check it out. So yeah, looks good. Me and my friend went to went to the store yesterday, and it also has added and we bought a lot of things. We got some food and drinks. Yep, looks good. If you compare both of them, looks really cool. But if you are an English linguist and you think that there is any mistake, please share it in the comments. Happy to revisit it, but looks really good to me. And finally, let's test this one out. Not only it has a lot of grammatical mistakes, but also it has got a very informal language, like me and my bro going to beach last week. Let's see if it can also fix that. Let's run it. It's very quick. It says me and my bro go to the beach last week and we have a lot of fun. So it doesn't fixes the informal language, but it does fix the grammar, which is quite good. So it does only one thing, does it nicely. That is quite good. And more importantly, now you know about another tool called as Happy Transformer, which is quite easy to use and another alternate of using transformers library. Anyway, let me know what do you think about this model and also this Happy Transformer. If you're already using it, please share your opinion. If you like the content and if you want to learn about more grammar models, please just search and you can see that I already have covered them. If you like the content, please consider subscribing to that channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.